Hey folks, and welcome to the first lesson for pre-calculus in our Larson book, section 1.1. So we're going to be looking at rectangular coordinates. Now, just to give you a heads up, a lot of this first chapter should be review for most of you. So hopefully this will be very familiar to you. We can just kind of breeze through it fairly quickly, but not too quickly. So the first thing is our Cartesian plane, which is our regular XY axis plane. So we can look at pairs of real numbers and represent them as points in a plane called the rectangular coordinate system or the Cartesian plane. So we have the X and Y axis, which forms our four quadrants. So if we wanted to just quickly draw a quick sketch of this. So we have our two axes that intersect, that go on forever in both directions. And we have our X is the horizontal and our Y is the vertical. Now, as far as trying to just identify the quadrants, there's a specific way that they do that. And again, you probably remember this, but the first quadrant is always the first upper right quadrant. And that is labeled with the Roman numeral 1. The second one is working counterclockwise. And if we keep going in that direction, we have our four quadrants. So the other thing to keep in mind is that the positive values are going to be on the right-hand side, negatives on the left, and then likewise positive on the upper part of the y-axis, and then negative values on the lower part. So if we wanted to represent an ordered pair, the technical format for that is to use parentheses around those two numbers. So the first number always being your X, second number always being your Y value, and that would be our ordered pair. Now, the first number, we can technically break that down even more, call it the X coordinate, and then the second number would be the Y coordinate. So now if we wanted to do this quick example, we just want to plot them and name the quadrant that they lie in. So -4, 1. So if we start at the origin, which I should have set up here, is the origin. So right here is the origin, and that would be the ordered pair 0, 0. So that's always your starting point. That's where all of your values should be based off of. So now for this one, -4, 1. If we start at the origin, we can work our way to the left 4 units, and then we want to go up 1 unit, which puts us right here. And we can label it. It's -4, 1. And the quadrant, based on up above, we can quickly see that should be quadrant 2. 3, 2, again, left, excuse me, right 3 and up 2 puts us right here. Label, and that would be quadrant 1. The next one, you guessed it, right? Should be in the third, so to the left 2 and down 3 puts us right here. And again, quick labels are always good to do. And then 1, -5, you guessed it, it's going to be in this last quadrant. So again, all this should be review. You remember how to plot points. So what can we do with them? Once you know how to plot points, what can you do with them? Well, the first thing we can do is find the distance between them. And luckily we have a nice formula that allows us to do that. And if you're not sure where that comes from, it is based off of the Pythagorean theorem. So c squared equals a squared plus b squared. So you need to know the specific X and Y coordinates for your 2 points and then just plug them into the right spots and break it down. And that's it. So let's do that. So we have the distance between 1, 3 and 4, 7. Now, if you want to just label them up above just to kind of make sure you have it all straight, go for it. Not a requirement. And then just plug and chug. So x2 minus x1. And don't forget those parentheses. And then y2 minus y1. And now follow the order of operations. Parentheses first, then your exponents second. So 4 minus 1 is 3. We can lose the parentheses since it's positive. And 7 minus 3 is 4. And now we can keep going. 9 plus 16, which equals the square root of 25, which equals 5. Now, obviously, if we don't have a perfect square, you can write it in reduced radical form. In some cases, you can use a decimal, but basically just follow the directions, whatever they say. So if they want it as an exact answer, then leave it in square root form, and just try to reduce it if you can. If you can't remember how to do that, just ask, and we can go through that. It's not a critical piece of the puzzle, though. So just getting down to that square root is the big thing. Now, some other applications, we could do the next problem that says, show the points form the vertices of the polygon. So we have a right triangle. So we have our 3 points here. Now, if you want to draw a sketch, it doesn't hurt. It doesn't have to be super glamorous, but we got a point in the 1st/4th quadrant. We have a point specifically in the 1st quadrant, and then we got a point in the 3rd quadrant. So you want to just kind of make sure you have your graph centered in a way that makes sense. So 4, 0 would be there, 2, 1, and -1, -5. So now, having it like that gives you, again, just an idea of what it looks like. So now, if you just want to connect the dots, just to kind of give you a better sense of your diagram, you could do that. And we can kind of see that the right angle is right there. So it doesn't look like it would fit there or there. So, all right, so now we just have to verify that we have a right triangle. So how do we do that? Well, we need the Pythagorean theorem. If the 3 sides satisfy the Pythagorean theorem, then we know it's a right triangle. So let's find the distance of each side, and then we'll go from there. So if we want to label it, let's call this one side 1, side 2, and side 3. Or let's use the Pythagorean theorem since we just referenced it. Let's call this one A, and B, and C. So A should be equal to square root of these 2 points. So that's going to be our first 2 here. So if we, now again, it doesn't matter how we order it as long as we keep it straight when we're plugging them into the formula. So if we want to do 4 minus 2 squared, and so we're going to want to go 0 minus 1. And so we can quickly break this down. So that's 2 squared plus a -1 squared. So 4 plus 1 equals the square root of 5. So that should be the length of A. So B, so now we want our 2nd point and our 3rd point for side B. I'll see if I can squeeze it in down here. So B, so these 2 points. So 2 minus, and be careful of those negatives, and then 1 minus a -5. So we got some double negatives that we got to just, be careful about. So 3 squared plus 1 plus 5, which is 6. So 6 squared. So it's going to be 9 plus 36, which equals the square root of 45. Okay, one more. And so now we're going to be looking at the first point and the last point. So if we use both of those, so we're going to have a 4 minus a -1 and a 0 minus a -5. So again, as long as you're just using that same pattern going from one point to the other and then back to the first one and then back to the second one, that's the key. So 4 minus -1 is 5. Minus -5 is 5. So 25 and 25, which is equal to the square root of 50. Now again, I'm not reducing them down to proper radical form. For these purposes, we can just kind of leave them as is. It's actually going to be easier, and you'll see why right now. So now we want to check the Pythagorean theorem. So let's plug in all of our values and see what happens. So we got 5, 40, square root of 5, square root of 45, and square root of 50. Now when we plug them in, we're squaring all those numbers, all those radicals. So what happens? Of course, they cancel. So we got that which we know is true. So the answer is yes. It does satisfy that it determines a right triangle. So we're good. So that's one major application of points in a plane, is just finding the distances between them in different applications. Another important one is finding the midpoint between them, and that's just a quick formula. So we have our 2 points, and then we plug them into the formula, which basically we're just averaging the x's and averaging the y's. Nothing fancy. So let's do that real quick. So we should say 1 plus 4 all over 2, and 3 plus 7 all over 2, which gives you 5 over 2, 10 over 2. Now, I'm not going to be too crazy about your final answer. If you want to use decimals, great. Decimals can be a little hairy when they're not, when they're repeating. So if you get these long or drawn out decimals, you might want to consider using the fraction form instead. So in this case, though, we could leave it as 5/2, or if you wanted to say 2.5, and of course 10 over 2 is 5, or some derivative of that would be fine. And that's it. So that would wrap up 1.1. So stay tuned for the next video, and we'll get into 1.2. See you soon.